Hey, so this is Major General retired Brian Watson, and you're president of your AEA, Army Engineer Association. And I just thank you up front for joining us on this evening for what I think, to be honest, may be our most important rally point ever because of the effort that is going on inside the regiment. And when you look at the capability of combat engineers, specifically in two areas, um, in breaching operations and terrain shaping, which we all know are going to be required across the force, all compos in the context of large scale combat operations. We're behind. And we could go through all the kinds of history, but we got to live in the here and now. And there are major efforts in the Army, which we're going to touch on tonight, major efforts down in units. You and I believe we are behind. You and I believe there are some solutions that are on the horizon that we can leverage now. Our job is make the Army believe it. And so we're going to talk about some of those efforts tonight. I think this is extremely important. And I'd like to, when I talk to the chief and ask who his lead is, it's General Chris Beck. And so, Chris, I'd like you to just open us up with a few comments. And thank you, sir, for you taking the time. I know you're a busy guy for spending some time with us tonight.
Brian, I really appreciate the opportunity to support Steve and the entire team and be part of this discussion. And I'll tell you to your opening comments, couldn't agree more. I know Steve and the team is going to talk about some of the great things going on throughout the regiment. But I'll tell you from a big Army perspective, this is probably one of the most exciting times I've seen in the Army. The rate, pace, and demand for change is unparalleled. The chief uses the term sense of urgency all the time. Chief of engineer or chief of staff of the Army uses the term sense of urgency all the time, and he uses it as we look at all the operational capabilities that the engineers bring to the table. So I will tell you that Army senior leaders, and I've had the opportunity to talk to all of them, understand a lot of the gaps you mentioned, and I'm excited for Steve and the team to talk about the ways that the regiment is working really hard, fully supported by MISCO, to get after those gaps to fix what the Army needs fixed. And I'm really excited about everything they've got going on. So I appreciate the opportunity to sit in today, and I'll stand by and I'll absolutely answer any questions if there are any. Over.
Hey, Steve, go ahead.
All right, sir.
Commandant, my commandant.
Yes. General Watson, General Beck, thank you. So General Beck laid out kind of upper level what's going on with our Army. We do have a mandate to change, something we talk about a lot in our regiment. We have a mandate to change how we do things. We get that from the Chief of Staff of the Army. Continuous transformation, one of his four focus areas. That's really what today's discussion is about. Your regiment, our regiment, is leading in many ways how our Army is moving forward and changing the way we do things. General Watson, you mentioned a couple of areas in the combat realm with breaching specifically, but really this is all of our disciplines. This is general engineering. This applies to topographic engineering. This applies to combat engineering. We are organizing as a regiment, right, around our own focus areas for disciplines. And you'll see a taste of that tonight as some units are talking about what they're doing, right? We have a lot of capabilities to bring to the Army, and we need to innovate across our front. So what you'll see is, especially on the active side so far, our brigades and battalions covering down on areas that are either important to them based on the talents they have in their formations, or based on some kind of guidance or direction they're getting from their local commanders in the field. What else are we doing? We've now met for a couple of months doing monthly innovation synchronization sessions with our regiment. Who's there? Units are there. Your schoolhouse is there. Army Futures Command is there. The labs are there, right? The PMs and product managers that help develop our capabilities are there. And we're talking about what we are doing on the leading edge of innovation for engineers. Those are exciting sessions. So if you're on the line here and you wear a uniform and you want to be a part of that or understand that, talk to your chain of command. And I would say, hey, I think General Watson, your intent here is to really junior leaders, right? And I'll define that as maybe majors and below talking to each other. So I want to get out of their way, because a lot of this innovation that we want really is going to be driven and is being driven by people who are equipped to change. So with that, my final thanks to my professional association, that is AEA, for sponsoring these events. I want to pass it on to the briefer. Thank you.
Okay, thanks, my commandant. So let's see, Mark Garrison, you ready to take it away?
Yes, sir. Ready to go. So,
Right.
Good evening, ladies and gentlemen. So I'm Major Mark Garrison, currently serving as the Chief of Engineer Concepts here at the Maneuver Support CDID at Fort Leonard Wood, which is part of Futures and Concept Center of Army Futures Command. So myself, along with Derek Sentinella and Mr. Jeremy Evans, make up your Engineer Concepts team here at the Maneuver Support CDID. So to start off this evening, I've been asked to briefly cover the phases of continuous transformation. That's how the Army plans to modernize across three distinct but interconnected time horizons. So what I would suggest is, if you'd like to learn a little more about this, I'd strongly recommend you take a look at General Rainey's 3 articles about continuous transformation that describes each phase and gives kind of some of the background behind it. And it's also a really good primer to understand the idea of not only continuous transformation a little better, but the Army warfighting concept, which is due to be published later this year, which is the driving document behind all of this. So, but before I outline the how of how the Army plans to tackle continuous transformation, I first kind of want to talk about the why, by covering some of the aspects of the future operational environment. So I would say, sir, if you wouldn't mind, go to the next slide. All right. So, as you've all seen with the wars in Ukraine and Gaza, so we're in a period of rapidly evolving technological advancements and changes in warfare. So, here in Army Futures Command, and especially in the concepts world, we focus on designing the Army of 2040, and that's based on that Army warfighting concept that I spoke about. And that concept acknowledges that with future warfare, some things will not change, like the requirement for close combat on land, or that warfare is going to remain a human endeavor, or that we as Americans are going to abide by the law of armed conflict. So those are not changing. However, there are several considerations that are expected to change. So the first, I'll start in the top left, work and work around, but the idea is the notion of an expanded operational environment. So that's across multiple dimensions, with increased density in the space, cyber, what's called the air, ground, littoral, and electromagnetic spectrum. So the concept of a more transparent battlefield, you're going to hear that a lot, but enabled by ubiquitous sensors across the battlefield framework, coupled with expanded long-range fires and the ability to near instantaneously transmit across that battlefield framework. So that's greatly increased the size and the complexity of the operational environment. Moving over, you've got protracted conflicts. So we're not going to be able to guarantee short wars, and we can't guarantee that wars won't escalate. So protracted conflicts will rise whenever there's stalemates, where penetration of gaps, especially as engineers, are required to gain that advantage. But the defense is going to get stronger, and offensive operations are going to become more costly in the future operating environment. So as a result, the commanders are going to have to use, in some cases, maneuver to enable fires, which is completely counter to how we've traditionally fought. The significance of the information domain, that would be the proliferation and combination of sensors, fires, communications, that's created a extremely lethal multi-domain strike complex, which will be our biggest challenge. Specifically, the timely and accurate transmission of information, that's going to be critical to making this work for us. And then also simultaneously targeting that and neutralizing the enemy's sensing and C2 capabilities are also foundational to our success. There's going to be a lower threshold for CBurn, specifically with the the threat of traditional chemical agents, that's still going to be there, but how do we protect against non-traditional agents, specifically like incapacitating agents or riot control agents, toxic chemicals, or like fentanyls? Those are all in a gray area, but how do we detect and protect that? Moving over into the OE transparency, proliferation of quality sensors across the depth of the battlefield framework, that's going to challenge our ability to hide. So we're going to be visible from the motor pool all the way to the flot, which is going to that'll manifest in the form of contested force projection, which we've usually not had to worry about, and then as well as contested logistics all the way through the operational framework. So while hiding may not be possible, how do we protect our critical capabilities, assets, and activities from being targeted? Considerations that we're talking specifically: dispersion, deception, layered protection, counter sensing. Those are all going to play an important role to combat that transparent battlefield. So likewise, that transparent battlefield is going to enable that a multi-domain strike complex, which I hit on a little bit, but those layered effects across all the domains, from adversaries that have advantages in both mass and magazine depth, complex attacks, so waves of fires from the ground, sea, air, all directions and trajectories are going to challenge projection across the OE. And then similar to the multi-domain strike complex is the growing prevalence of uncrewed systems, which is just everybody knows that. But we've all seen that rapid proliferation of drones in Ukraine that are enabling massed short-range precision, and that's only going to get worse. So unmanned, massed, and eventually swarms of uncrewed systems are going to exist across the battlefield framework, both for us and our adversaries. So how do we control our uncrewed systems and simultaneously protect from enemy systems? So we should be concerned with how we can leverage AI and machine learning to enable the C2 of those systems, and simultaneously we've got to focus on how we can use human-machine integrated formations to increase that standoff, increase the capacity, and remove soldiers from the most dangerous parts of the battlefield, and place a specific focus on offloading those dangerous, dirty, and dull tasks to those uncrewed systems. Again, we'll also see the future battlefield's going to require us to move through unavoidable urban terrain, and that's just going to present yet another challenge to maneuver. And then there's also the emerging idea of contested air-ground littoral, and that's the space between the ground and a few thousand feet AGL. So we've got to simultaneously manage, operate, and protect in that space. And I see this as a major consideration in both engagement area development and obstacle planning. As engineers, we've got to place increased emphasis on that air-ground littoral in our MACU and employ those lethal and non-lethal effectors to shape this space as a part of that combined arms force. And then I'd say lastly, the layer protection, that doesn't only include like an integrated air defense system, but that's in a larger sense, it's a multi-domain obstacle. So belts that are comprised of land obstacles, but also air defense, EW, cyberspace, layering all of those protection assets to protect our force. So we must be able to penetrate the multi-domain obstacle belts as well as establishing them. So given that, the question is, given that future warfighting problem, how do we build an Army as a warfighting institution that succeeds across all those time horizons? And the theory is continuous transformation, which leads me into my next slide. So continuous transformation, it's all about how we account for uncertainty and manage transformation across those 3 periods of time that you see there, as opposed to deciding whether or not we prioritize current and future readiness. So the concept of continuous transformation, it involves really 2 types of change: changes that we can make now and changes that we can make only if we start now. And each of those periods, they're interrelated, and the concepts are going to inform the transformation in contact, which will then influence science and technology. It'll inform deliberate transformation, and that's going to help deliver the force of the future. So something to keep in mind is that to have a capability by 2040, we have to field it by 2030, and this is generally, but have to field it by 2035, which means we need to prototype it by 2030, which means we have to program initial budgets for it by 25. So just think about that. 2040 is going to get here a lot quicker than we think. So it's important that we're communicating across the regiment and across all of these phases. So the first period is transformation and contact. So that's kind of the 18 to 24 months. That time frame focuses specifically on those immediate changes that are ongoing modernization efforts that are using operational units as a test bed, like we'll hear tonight. That's going to involve deploying the new capabilities to warfighters for testing and analysis to get real world feedback and inform future adjustments. So that is going to be focused specifically on technologies with revolutionary potential that could be useful to operational units right now. So even if it's in small quantities, using it and integrating it right now. So those cutting edge technologies that are commercial off the shelf, that allow units to inform the organization, training, and equipping of the future force. And then,
Hey, Mark, so the thing here for this group is the center of gravity, the tactical edge is really all about this transformation and contact. Industry plays a part in that, but industry, science, technology really begin to help us with this more deliberate transformation. And then we're thinking about concept-driven transformation out in the future. But all this is going on simultaneous.
acknowledge, sir.
Okay.
And then again,
we got a lot of people, so we're going to.
All right, I'll move quickly. So that's going to accelerate employment and maturation of the technology, and then moving over into deliberate transformation. That's specifically what you would see Army level processes guided by force management, development, and integration, all those support systems. So folks like John Armstrong here in the requirements side, and all the folks over in OCE and G8 and G357 who's going to fight the R-Struck and the POM battles over in the Pentagon. But it's a prescriptive process, but I think the big change to note here would be shifting the focus of requirements documents on capabilities as opposed to systems. And then the final period is concept-driven transformation. That's where I sit. A long-term process driven by the Army warfighting concept, and it's doctrine and resource agnostic. So it focuses on what should be, driven by a threat-based and capability-based gaps that result from that changing operational environment that I described. So outside of that, I would say if you take nothing else away from this slide, understand that it's imperative that the three phases of transformation don't take place in isolation. Understand how they're all interrelated, and they've got to inform one another, and it's crucial for maintaining the Army's effectiveness as that battlefield becomes increasingly more complex and technologically advanced. So that's it for me. Pending any questions, I think Becky's going to follow me over in G8.
So Mark, really important because the field needs to know these three different phases all going on simultaneous and really all different parts of the Army, and where they have the most influences in this transformation contact, which we're going to talk about tonight. So I really appreciate you putting that in context.
Absolutely, sir.
Okay, let's see. Our next briefer. Becky, I think that's you, right?
Yes, sir. Good evening. So Mark said a couple of things that were music to my ears. To speak in terms of capabilities, not systems specific. And we're talking about resource agnostic. So I am going to go ahead and get rolling. So good evening, sir. And good evening to my fellow engineers. Greetings from very balmy Arlington, Virginia. So for the rest of the group, it's no secret that engineers across the formation do find innovative ways to use the tools that we already have. But the current conflicts in Ukraine and in the Middle East have given us a sobering view of the modern battlefield, forcing us to take a hard look at where we need to modernize our capabilities. We've got a resource-constrained environment, not just fiscally, but when we look at our sources of manpower and the other constraint that we have, time, in terms of training hours. So, you know, looking across all of those things, it makes it difficult for us as a regiment. But this evening, I'm going to share with you our efforts from the Assured Mobility Branch in the G8 And we are the branch responsible for synchronizing those procurement efforts for the hardware that everyone sees there in the middle of the slide. So what everyone sees on their screen are two main priorities. So the first is modernizing the assured mobility capabilities through the combat, general, and geospatial engineering modernization. And then the second is upgrading and synchronizing engagement area development solutions. And these things also do kind of go hand in hand, but they are very distinct priorities as well. And then we've got 5 lines of effort, and they span from 18 months to 10 or more years. And as Mark was already discussing, those years from flash to bang, from when we have to start budgeting for that money until we start seeing those first unit equipped, it seems like it is a very long time, but 2040 will in fact be upon us very quickly. But the space that we are operating in is right in the middle of that slide, where you see that deliberate transformation timeline, with the goal being to get those first units equipped somewhere in that midterm, that 5-year range, with everyone equipped with everything that they need as we're hitting that 10-year mark. So as we're hitting that 2040 mark. So as we go through the slide, you're going to notice some interdependencies between some of those modernization efforts. So it's important to know that some of these really are interdependent with one another. So we're gonna start with terrain shaping and breaching. So they're not right next to each other on this slide, but they are very closely linked. So we're talking about those efforts that are vital in shaping the battlefield and making sure that our friendly forces can access terrain effectively while decisively restricting the mobility of our adversaries. Right now, this is the top priority of the regiment. And it really is important to note that the era of just deploying rows indiscriminately of mines is over. The introduction of robotically placed terrain shaping mines allows really for precision obstacle emplacement and networked munitions. So not only can we rapidly emplace these obstacles without putting our own troops at risk, but we can also minimize long-term risks to civilian populations. So terrain shaping operations really don't have to be limited to one specific platform. And the idea is that they can be inclusive of launched effects as well as ground capabilities, which is why I was just tickled pink when Mark mentioned, that we've got this platform agnostic and we're speaking to capabilities and not necessarily a specific platform. Similarly, we're talking about enhancing our ability to breach explosive obstacles. So the efforts right now are underway to modernize explosive and mechanical breaching capability by adopting robotic technologies. So similar to terrain shaping, we're seeking those solutions that we're going to call more platform agnostic, and that different aerial and ground-based platforms could support multiple munitions payloads. Again, looking at overarching capability in what we need to do, not so much married to what it is called specifically. We need to focus in on what it is we need to accomplish. These capabilities will not only support the directive of no blood on first contact for sappers in the breach, but it's important to note that they could further refine the role of combat engineers companies in supporting our maneuver forces by providing time and space to better capitalize on the engineer's ability to help solve other battlefield problems. Additionally, we've got the assault breacher, the ABV and the Joint Assault Bridge, which is the JAB, which are critical to the armored force. So as we look at those, we're looking at those bridging programs that need to be modernized. So they tie in, they're part of the bridging program, but they are crucial in breaching operations for the armored formation. So they are providing much needed mobility. So with the ABV specifically, we do have tentative dates to start rolling out a remote control applique for the ABV. This would allow the system to conduct that breaching, proofing, and marking without having personnel in the breach. So the intent is for that system to start off as a limited release. And we've received positive feedback that the system's pretty intuitive and that the armor community sees that as a win. The following bridge capabilities that we're looking at for modernizing with robotic integration would also include wet gap crossing capability and other tactical bridging options. So out of necessity, we have multiple bridging solutions to meet various requirements. There's really no Swiss Army knife or no one-size-fits-all type option for bridging. But we still have to seek ways to minimize our combat engineers' exposure if they have to dismount to deploy these bridging systems. So ideally, we're going to get to a point where our combat engineers are not going to have to dismount at all to deploy a tactical bridge. So think like reps. Right now, they have to dismount. They have to get out of the CBT to deploy that bridge. The goal here is that they can stay buttoned up and they can get that bridge launched without ever having to get out of the vehicle. A lot of times we also don't think much about survivability, but it is rather important. And when we think survivability, we're really thinking about construction equipment, and we're thinking about those armored personnel carriers. So every survivability is kind of an all-encompassing group of equipment, and they frequently kind of go unnoticed. So combat engineers are going to utilize those dozers as well to help breach obstacles. The bridging units are going to use them for wet gap crossing, and the dozers are going to be used for airfield construction, as well as S-pods and putting in berms and hardening positions. We also do have other boats and other equipment that falls within the realm of construction. I was looking at the text. I apologize, sir. So, there's just so much in the construction realm that for quite some time has kind of been set aside as something that has not received a lot of funding. However, a lot of our construction equipment, if not all, is commercial. And right now, we are in a position where we really do have to start modernizing that equipment because the companies that we've been getting that equipment from no longer make that equipment. So you'll see on the slide there that there is a move to update the Hi-X's, the loaders, the graders, and really make a push to modernize that equipment and start moving toward that robotic and autonomous construction equipment. That is where the commercial side of construction industry is headed, and they've made significant strides. So that is the direction that we will also start looking in. Additionally, as we are working on divesting fully the M113s and getting our engineers out of those, we are moving into the Bradleys and then eventually into the AMP-V engineer variants. And then I don't want to take too much time, but I do also want to touch on geospatial. So this is something that also has not gotten quite as much attention as it probably needed to have. But with an increased focus on autonomy and a lot of the networking that we're discussing with the different types of vehicles and capabilities, this is going to become increasingly important to make sure that our combat engineers have maximum fidelity on locations and terrain, and to make sure that maneuver commanders can, in fact, stay tied into where the battle space is. Right now, there are lines of effort to procure systems that are more modular in nature that would allow us to replace components as new technology emerges, rather than have to acquire brand new systems wholesale when something new comes out. That would allow us to stay on top of emerging technologies and stay relevant without having to invest in something completely new and run into the situation that we have been in the past, where our systems become obsolete unnecessarily, and then we suffer from having a big capability gap. And pending any questions right now, that's pretty much where we're at. I think Mark actually stole a little of my thunder with where the funding needs to start to get to where we need to go. But without giving too much away or going into anything CUI, I just wanted to paint a picture of kind of where we're headed.
Yeah, thanks, Rebecca. I appreciate it because, you can see there are things that are going on as part of this transformation contact. The things in yellow are part of this deliberate transformation. And you're kind of, at the leading edge of that up in G8 as one of our SSOs. So I really appreciate that. Josh Gallagher, over to you. And now talking about getting down to the tactical units, how do the brigades fit into this?
Yes, sir. Generals, team, good evening. As far as the brigades, see, I'm Major Gallagher with the Engineer School, Army Air National Guard Force Integrator. The shaping operations for the current 6 active duty brigades are listed here on the slide. I mean, you can read them. So we are looking for lessons learned, obviously, from both our civilian partners as well as military partners in modernizing the force with innovation. Part of the innovation is the transformation contact, which has also previously been spoken about by Major Garrison. Switch government and commercial off-the-shelf hardware software. It's being used to modernize the formation. We're using the technology and resources that are currently available or will be available within the next few years, the next couple of years, to help the force out with their current problem sets. Another part of the transformation is the deliberate transformation, in which innovation areas such as bridging, breaching, terrain shaping, etc., are utilizing human-machine integration, HMI, to leverage the technology that improves survivability on the battlefield to support our formations by 2030. And something that's already been touched upon in both the previous briefers are the unmanned aerial systems and UAVs. Obviously, you can go to YouTube and look up all these videos in Ukraine, and you can just see and just envision the lessons learned that they have garnered from this technology. It's cheap, easy to produce, and can be very effective in a large-scale combat environment, which we've seen over past. It's been almost 3 years since that conflict or the war has started over there. Some other technologies being used here shown are the small multi-purpose equipment transport. It's a robotic vehicle, a light. Obviously, you can see it's mounted with a weapon system. I'm sure it can be configured to different things depending on the situation. So that using this will also help minimize soldiers in the breach, to minimize the casualties. And that all this technology here and all these different pieces of equipment will also posturing us for the current as well as the future operational environment. The other item here, the ribbon bridge. So obviously that is a very labor-intensive manpower operation here. Obviously there's sling load. You've got the soldiers on the bridge ready to receive that. So with the HMI, the human machine integration, that is something that's looking to help us minimize casualties, keep soldiers out of the breach, including the ribbon bridge. There's processes and ideas in place to help move that towards more of an autonomous situation. While it may not remove all soldiers from the breach, it will help minimize their exposure. Pending any questions, sir?
Hey, Josh, thanks for that, because, and then for the group, this is change right here. So you've got active duty brigades right now that the chief and then the Army are looking to head specific areas, both in transformation and contact, and then also informing this delivered transformation. That is new. So here's the message. When you get to these units, you need to understand how your role, what you are bringing to the Army when you're going on these training exercises and these experiments that we're going to be running. It is absolutely vital, and your voice needs to be heard. So thanks, Josh, for bringing that up. Well, let's go to I believe it's Captain Jack Young, who is in the Rugged Brigade. You're up next, sir.
Yes, sir. Thank you, sir. Good evening, team. I'm going to touch on the 36th Engineer Brigade and our program. I'm Captain Jack Young, the training officer and also innovation officer for the brigade. And picking up from where we left off in the last brief, I'm going to explain what TIC looks like and this transformation contact to a unit and how we've built our program, some challenges we faced along the way, and then some of the capabilities and assets we've seen and are looking to get, and then our ultimate timeline and goals with our program going out for the next few years.
Yeah, so Jack, just to help me out here. This is happening now. This isn't something that we're, talking about, we're doing in the future. It's happening now. You're seeing it, smelling it, feeling it. True?
Yes, sir.
Yeah.
Yes, sir. It's an active program.
All right,
An
good.
active program with an active goal, both in the short term and long term in our sites.
All right, bring it home, man.
Yes, sir. So 3 Corps directed us to develop an autonomous armored breaching capability, ultimately to show at the Armored Leader Summit in October of this year. And part of the impetus to this ask was because the 36th Engineer Brigade is going to be falling under the 1st Cav Division in the near future, and we will be habitually aligned to their brigades, and 1st Brigade, 1st Cav will be part of TIC 2.0 leading up to an NTC rotation in 2027. So that was an ask, and then the Engineer Schoolhouse, to build on this effort, wanted us to explore what the .mil PF answer to an HMI KEC looks like. So to begin to look into how the structure changes. And I saw a question in the chat about, will engineers still be operating the equipment? That's another question to ponder as we go through all this. Is it engineers still operating all this, or is there a new MOS? And just what all that looks like, and then how all this equipment interacts in our current doctrine, and what changes will be necessary. So some challenges we faced right off the bat. First was probably funding, trying to identify what funding sources are available and how we can utilize different streams of funding, we found that the most the easiest route was probably building off of existing programs through Army Research Labs, Army Application Labs, ERDIC, DevCom, different partners, and seeing what they're working on and seeing how we can provide benefit and how they can benefit our program also. A couple other challenges were current installation and range control policies. So introducing UAS to training areas and just the whole idea of RCVs and unmanned vehicles in the training area and what the safety on that looks like and what areas and ranges can be repurposed to help support these efforts, such as using UAS to drop crater charges or other charges and unmanned vehicles maneuvering through the terrain. And then a couple more unit level challenges. We're trying to balance out competing training requirements and the directed missions while still doing this effort. So maintaining momentum with the directed requirements, but also pushing hard on this effort. So we found that we've designated one company from the 20th Engineer Battalion, the 59th Keck A, to be the unit testing this equipment going forward. That battalion will be aligned to 1st Brigade, 1st Cav in the future, and they will ultimately be going to the NTC rotation. So they will be the unit that these assets are going to test out this new formation. And then the last bullet I have there, the communication with all the stakeholders we've made between the engineer schoolhouse, the chief of engineer's office, ERDIC, DevCom, all our different partners, making sure that they're up to date with where we're at in our experiments and who we've been talking to. And then also the education on both the technical side of robotics, autonomy, UAS, but then the education of like the Palm cycle, for instance, like the G8 spoke about, and what impact, what goals are short-term goals that are able to be accomplished and which ones are more long-term goals in acquiring equipment, and just balancing that and learning what we can and can't do and what's possible. So going to our methodology, we see our opportunity or our unit as an opportunity for programs and companies to bring assets, and when we have soldiers that can provide data and feedback. So we set up soldier touch points, and we'll be the bed testing them out. They'll be getting data, but then we'll also be working towards our own goals for this project and taking our own data from it. And then another, so big picture with the beginning of this project was to first come up with who's out there, what's out there, so who's been working on what, and learning who the team is. So between the engineer schoolhouse, ERDIC, specifically Searle, and then DevCom teams, just figuring out who are the right partners and who has the research and assets and who's been working in this field that we need to partner with. And then lastly, building the relationships with our installation staff. So the core staff, and then specifically range control, because range control will play a big piece with allowing us to fire MICLIC and a TA, which has not been done in years on Fort Cavazos, and flying UAS in certain areas. Next, I will hit some of our capabilities of interest that we've seen. So I'll start in the top left down there. So DevCom's working on a detection UAS. We saw that back in September at Redstone Arsenal. That's part of the Goblin program, trying to find a UAS to do both surface and subsurface detection capability. And then another company that's working in the UAS space is Service. They've been working with ARL through Futures Command. That's another effort that we're trying to draft off of the funding that's coming from ARL to procure some service, TRV 150 specifically. That capability is specifically for the neutralization of Dragon's Teeth and also obscuration, so dropping smoke before the breach. And then a couple other UAS that we've seen, the Lasso and the Scout Recon. And then as far as getting into vehicles, the DARPA Racer program is our our main partner in the vehicle space, along with the ABV RCS. Those are the two main vehicles we found. The DARPA Racer program is a program up in Washington. They've teamed with Overland AI, a company working on autonomy, and the DARPA Racer program was trying to develop a ground-based autonomy that's good in all terrain. That was their focus. And we're trying to make that mission oriented. So we're going to put a MICLIC on top of that vehicle. We've been in talks with the team out there to mount that and then to test that vehicle throughout our learning activities that we have planned leading up to October. And then the ABV RCS, that's another asset. So that's been mentioned before, but that remote controlled system for the ABV to do the neutralization, the proofing, and the marking. And then ultimately with these efforts, I've heard the word brought up a couple times, the vehicle agnostic. So coming up with autonomy kit or a remote control kit that isn't vehicle locked to just the ABV or to that DARPA Racer platform, which it's an M5 Textron platform, so not an Army inventory vehicle. So finding a kit that potentially could go on the 113 to be a to use for the next few years before we can get new vehicles or a new system. Next, I'll hit on the dozers down there. So CAT Defense has been working on a next-gen D7, a teleop D7, and then they've augmented a D7 with a full-width mine plow. So different approaches to proofing between the remote control kit and then the D7, the next-gen D7 with CAT assist features that they're in the nascent stages of doing ABDs and other D7 operations autonomously. They're working through that, and there's great progress in that field. And then lastly, I'll hit on the Pearson RCV Pioneer plow. So a big discussion in this space is proofing, and if a RCV has enough capability, like oomph, to actually proof effectively. So Pearson, a company in the UK who makes the ABV plow, they've been working on a series of modified plows that have a track width plow in the front with a full width in the back so it can pull a plow. They've been experimenting with different ideas, and they plan to continue experimenting to see what is possible. And we're talking to them, we're working with them, and hoping that something has success and that we can bring this into our efforts here. Slide, please. Thank you. So for the timeline, big picture timeline is 3 learning activities this year leading up to the Armored Leader Summit in October. And then going forward, we'll be teamed up with First Cav with their TIC 2.0 efforts leading up to Pegasus Forge in late 26, early 27, and then NTC where the TIC 2.0 testing event will happen. So learning activity 1 will occur at Fort Cavazos in early April. That's where we're going to start to bring together some of these technologies, and then we're going to continue to build on this throughout learning activities 2 and 3 in early June and August, ultimately leading to October, where that will be our answer in the short term to what we think could be an answer to a KEK A, an HMI KEK A, and try to answer some of the questions that we're trying to solve. And along the way, we're also going to attend MISPICS, PCC 5. And then one thing I failed to mention in the beginning, another effort that CORE has asked us to do is a complex obstacle belt in one of the TAs at Fort Cavazos, permanent obstacle belt for units to test on and train on before mainly NTC rotations or other training center rotations. And specifically a complex obstacle belt. So the new obstacle belts that we're seeing in Ukraine and that NTC and JMRC have been planning. And so we've met with the teams out there to plan our obstacle belt, and that will be our testing site for the UAS, RCVs, and other dozers and the other assets that we pull together. Pending any questions, that concludes my brief.
Hey, Jack, it's perfect. for the group, what you ought to take away from this is that there is an incredible network of people that are working all parts of this. And so here you got Jack down in the Rugged Brigade, a tactical unit leader. You know, I'm not sure whether he's really an innovation officer, but okay, we'll call it that. But here's the thing. All of us have to expand what we normally think of as our area of operations and our area of influence. You've got to learn how these things go in the building. You've got to learn what the role of ERDIC is. How does Army Futures Command? If you want to help this regiment, you have to own this fight. And what's different about this tick is that we're moving ownership further down into tactical units, as you can see in Jack. So, hey, Jack, great brief.
Thank you, sir.
Yeah, so let's go to Matt. Here's another example. Matt, take us through what we're doing in MRBC. Again, something that is happening now.
Hey, good evening, everyone. My name is Captain Whitley, and I'm the commander of the 497th MRBC. To showcase our innovations from the... No, it's all good, sir. To showcase our innovations from the field, we'll be talking our improvements to wet gap crossing with the goal of making portions of a wet gap crossing operation autonomous to provide greater safety for soldiers and by removing them from the slip and by providing tactical flexibility to MRBCs. We all know that there's, whether or not it's breaching or doing a wet gap, these operations are incredibly complex and they're very dangerous. Independent of the enemy actions, the usage of our current equipment set that we have available to us as MRBCs poses significant risk to our soldiers, which we'll talk here in a little bit. This innovation was inspired by the 20th Engineer Brigade's Sandhills project, and it was a soldier-led initiative from some of our 12 Charlies working with the Modern Innovation Center here at Fort Stewart. In light of the goal of increasing mission success while simultaneously providing an increased measure of safety for our soldiers, we came up with a modification of a product with an end goal of providing an autonomous capability forward of the engineer equipment park for MRBCs to be implemented across all of the fleets. So I'll be handing it over to Lieutenant Olivia Carter, who is one of my platoon leaders, whose platoon has spearheaded our innovation projects. She'll be briefing what we've been able to achieve over the past 6 months. So Olivia, I'll hand it off to you.
Thank you, sir. Good evening, everyone. Like Captain Whitley just mentioned, my name is Lieutenant Carter. I'm currently the platoon leader for 2nd Platoon here at 497th. Our motivation to design what we call CAPS was inspired by two main concerns that we had. So number one being soldier safety at the slip in both training and combat environments. And number two being the need for redundancy and flexibility on a system that isn't necessarily reliable for us all of the time. So in order to explain CAPS most effectively, I'm going to first take the group through our current launching process, and then step by step, we'll be able to identify the key changes that we've made through our initiative. But before we do that, I'd first like to just quickly orient everyone to some basic equipment that we use in an MRBC. So first and foremost, we'll have our Common Bridge Transporter, or our CBT, which you'll see there top center of the slide. And this is essentially just a PLS type platform that helps us transport boats, bays, and ramps down to our launching site. And then on the CBT is going to sit what's called a bridge adapter pallet, or a BAP. And it's kind of hard to see in the picture, but it's basically an A-frame that helps secure whatever load we're carrying to the CBT for transport. And then lastly, you'll see highlighted in the picture, we have two front pin locks, one on each side, and then two rear guide assemblies, which you'll hear us refer to as dog ears, again, one on each side of the CBT. And both of these locks are just locking mechanisms that, again, help hold the load onto the BAP and the CBT during transport or movement that we might be doing as a unit. So now the important part, how do we actually get this stuff into the water? And I've included a basic launch sequence on the slide for reference, but the first step is going to be actually lining that CBT up to the slip for launch, and that includes ground guiding it in. So right off the bat, in addition to your driver of the CBT, you're going to have two additional soldiers at the launching site for both front and rear ground guiding. And this is where the first key piece of CAPS comes in. So two of my soldiers, Specialist Cooper and Specialist Duncan, have worked extremely hard to mount a backup camera to the rear of the CBT. And what this does is it enables that driver in the cab to independently maneuver their truck into the slip. And therefore, we're already eliminating those two extra bodies that we had there on the slip for ground guiding. Another key part of the launch is going to be when the CBT hits depth. And I'm going to go a little out of order here for simplicity's sake so that I can group the locking mechanisms that we'll talk about next together. But typically our minimum launching depth is 3 feet, and you'll have a soldier on the shore who is there to tell the driver once they've gone deep enough for launch. So in order to eliminate that manpower, we've installed a depth sensor to the rear of the vehicle as well that illuminates a red light in the cab for the driver to see once they're at that suitable depth. So again, just adding small systems onto the CBT, we're reducing manpower at the slip using another segment of caps. And then lastly, with that depth indication, the driver can then release both the front pin locks and the dog ear, utilizing switches that we've wired right next to that light that will both activate an actuator on each respective lock. So before the installation of caps, our current launching process actually required a manual release of both of those locks. And depending on certain factors, this sometimes actually required soldiers to go into the water and release them while the CBT was pulling forward out of the slip. So it was precisely there that we saw our biggest threat in a training environment specifically, mostly in the form of soldiers slipping and potentially being crushed by the vehicle. That's what we saw as our biggest risk during training, especially when you're training at night. So again, just highlights how CAPS is extremely focused on soldier safety in a training environment. Now, to caveat off of the concerns that I mentioned earlier about a combat environment, I wanted to specifically highlight the process of releasing those front pin locks. So currently, without CAPS, it's done by the driver who they'll reach out the window, grab a tagline that's attached to the lock, and they pull it. So you can see on that picture, we've thrown in, it's like that yellow line that reaches from the cab to that front pin lock. So you essentially have a driver under NVDs at night, one hand on the wheel, leaning out the window while driving forward out of the slip and simultaneously pulling that line to release the bay off of the CBT. So if this tagline fails, that's when those soldiers are forced to go into the water for a manual release. And with that in mind, up-armored CBTs don't have the capability to roll down those windows. So in combat environments, you're automatically defaulting to 2 additional soldiers at the slip who are exposed to not only enemy threats, but again, those same dangers of just being right next to a moving vehicle in water at night. So with that launching process explained, you're looking at a total of about 4 to 5 soldiers working the slip for one successful launch. And what CAPS enables us to do is reduce that number down to 1, and that's going to be your actual driver, the CBT. So CAPS effectively eliminates all unnecessary manpower from the slip. And I really just want to kind of give a shout out to our soldiers here. They've been able to spearhead this with only about $450 to Amazon. So really just showing that they've been able to think critically and come up with some really brilliant ideas. And we've been super lucky to be a part of it. But our next goal with CAPS is going to be obviously to remove that last soldier from harm's way, right? Because every soldier matters. We want to get that driver out of harm's way as well. And with that, I'm going to hand it back to Captain Whitley to discuss the next steps in order to do so.
Hey, Olivia, before you go.
Yes, sir.
So there was a question. Has this been documented and where can the field get it?
Yes, sir. So we've been working with the Marna Innovation Center we still have some refinements that we want to make to the system. So obviously the first step was writing a paper to kind of keep documented the steps that we've made so far. And then working on some refinements before we potentially try to install it on other vehicles.
Okay, well, look, I've got a magazine that goes out to every battalion across all composts, 10 copies. you give me that article, we'll get it in there.
Yes, sir. I appreciate it.
Okay.
Sir, don't worry. Olivia submitted the HMI competition last month, so the article's already been received.
Okay, good. And then the last thing, just for Olivia, and then we'll go back to the next briefer. But when we talk about human machine integration, we all immediately jump to these robots and things. But what Olivia's soldiers have demonstrated is we have to rethink the way we do business. I mean, this is the lowest level. And so, Olivia, to your outfit, my thanks for really thinking out of the box and getting after it.
Appreciate it, sir. Thank you.
And so if you'll move to the next slide, we'll talk about the path forward for MRBCs. So currently we're working with the Marne Innovation Center to receive autonomous PLS systems that are currently in existence at Fort Johnson. Once those systems get transferred to 3ID and then subsequently to us, we'll be able to take the navigations and control systems within that PLS and either take the bridge adapter pallet that we currently have on our common bridge transporters and put it on the PLS for launching procedures, or take that system out of the PLS and implement it within a CBT. So currently, Olivia has walked you through phase one, which is the improvement and the development of a currently existing piece of equipment that we could handle at our level. Phase two is the small scale implementation of integrating the new improved system that we have with an autonomous platform. And then phase three is conducting this at mass. So once we work out the tricks of getting this autonomous PLS to safely navigate from the EEP when the equipment is prepped, and then to go down to the slip, do that 3-point turn, and then back into the slip for release with the CAPS BAP, then we can implement that across multiple CBTs or PLSs, because there's about a platoon's worth of these PLSs currently in existence right now, to conduct a blended breach where we have bridge crew members conducting the build, and we've got bridge crew members dropping the boats in the water. But for the bays, those will be dropped completely by autonomous systems to increase our tactical flexibility so that we have soldiers that are able to prep more bays quickly up at the engineer equipment park, and that we have more soldiers available to be putting onto build crews for multiple center lines. So this provides us a significant amount of flexibility. There's a lot of options here. And then once these products are finally refined, we're already talking with the other MRBCs about what we've done, but fully implementing them across the force. Just to upgrade a handful of your systems for a total cost of roughly $500 to greatly improve soldier safety, particularly in blackout conditions, and then to remove that 12 Charlie from the slip, a super static and vulnerable position, as a huge win. So a very big credit to Lieutenant Carter, Specialist Cooper, for really making the work happen on identifying these issues and then troubleshooting the process and iteratively going through this innovation process to get a product that works.
Joe, you just remind me what an amazing regiment I used to belong to. And that has leaders like you, soldiers like you have, who not only are solving the problem right now, but also thinking about a path forward in a very innovative way. So my sincere thanks to you, sir.
Yes, sir. Thank you.
Okay, so I'm just going to go through. I know we're at time. I'm hoping that people won't just drop off. I ask you just to indulge, because there were some great questions that kind of got brought up. One of those is we kind of hit this idea of human machine integration, and we all immediately jump to robots. And so, anybody can chime in, maybe the commandant, the CG. Is it really all about human machine integration, or are there this modernization effort? It's also bigger than that. It's, you can do all the human machine integration to a MICLIC. That might get us at least moving, but we all have to admit the MICLIC as an explosive device is probably not there yet. So not there anymore. So anybody want to take that one on?
Hey, sir. Steve Kaluch here. I'll take the bait. So Captain Jack from Fort Cavazos he warmed my heart when he uttered the expression "mil PF." Right, something we're preaching here with units in the enterprise here is it's not just about the materiel. Right, we call it like the campfire. We all want to look at it. It's the most alluring thing. You get lulled into it thinking that's the only game in town. And it's very important. Sometimes it's something necessary, but by itself it's not sufficient, as we know. So, right, it's the doctrine piece. It's the how do we organize for this capability? Train and educate TTPs, personnel policy facilities, the whole gamut. And so that's really where the gold is. That's something that General Beck's been stressing to us. That is not just materiel. And I saw some stuff in the chat there. There's not enough stuff to go around. Not enough material to go around. That's probably something that's immutable. It's probably something that you have when you were an active soldier, and it's going to be the truth in the future. Never going to have enough stuff. But what we can do is we can work on the non-material aspect of integrating capabilities, and how do we have to adapt during this mandate of change. So there's my response, sir.
Yeah, and one of the other questions that came up, see, we've got TIC. So this transformation in contact, we got sort of iteration 1.0. The iteration 2.0 is ongoing. Obviously 36 is involved in that. Others are involved in 2.0. But I think until people really understand that it depends on what unit you're in, what part of this transformation in contact you're going to have based on these focus areas. How are we setting the table for 3.0?
All right, sir. And I'm going against my guidance about only having majors and below talk with you. But so I would say this, other things we're preaching.
I'm letting you talk to the majors and below, man.
All right, God, no, thank you. I would say this, two things. Don't wait to be told to do something.
Thank you.
Don't wait for the order to come out from your higher or your higher's higher directing you to do this, that, or other. Some of the neatest things you're seeing, sir, and you've seen only some of them here right now that are emerging. They are emerging. These are true bottom-up type things. And that's the real, I've heard General George a couple of times mention like that our soldiers get it. Our younger or junior officers, they get it. It's folks like me that are the problem if there's a problem. And kind of, listen to them, give them some resources and get out of their way a little bit, right? And we're going to learn some things. So don't wait to be told something. And then also kind of something I took personally from watching 18th Airborne Corps is, think big, dream big, be bold, take some risks. Is something that coupled with people who have a passion for something, an interest, and that's where we're going to find some progress. And then my final point, sir, is again something that General Beck's harping on, rightfully so. A lot of learning going on, a lot of effort, a lot of passionate work, which is awesome. I think our regiment's job, right, the commandant's team job, is to make sure we're talking as a regiment, so we're learning in somewhat of a coherent manner. So we don't have multiple brigades learning identical lessons when we can use our resources, including our time, more wisely. So having no learning demands. And that's part of what's behind why we're meeting monthly as units and why we asked you to host this topic here tonight, sir. Over.
Yeah, perfect. So look, there's some things that are, in the works. Many of you will come to Regimental Week. This is going to be one of the hot topics. We listened to the 36 kind of laying out some timelines. We've got similar timelines for TIC 2.0. We've got to get set for TIC 3.0. This will be a major discussion at Regimental Week. So for the engineer leaders, and I mean leaders at all levels, make an effort to get to Regimental Week so that your voice is heard in these important meetings. I think that's really important. And then also, I can't say it enough. If there's innovation going on in units, let your engineer magazine carry that message to you. Okay. There's no more widely distributed magazine within our regiment. All compos, all battalions, brigades, districts, 10 copies each, 4 times a year. So help us do that. And then obviously, there's also the online content. We'll be happy to hang anything for you. I think we're rounds complete. I'll give General Beck, sir, if you're still on, any final words?
Brian, thank you. And I'll just say one quick thing quickly, and I'll reinforce what Colonel Kaluch said previously. First of all, great discussion. And this just highlights how incredible the innovation throughout the regiment right now is. It's incredible. And it is driving change at a pace and capabilities from the bottom up that is unparalleled. But the one thing I'll reinforce that Colonel Kaluch mentioned is, as you innovate at the lowest level, you've got to stay connected to the schoolhouse. As General Watson said, publish articles, all that stuff is critically important to get that out, but you've got to stay connected back to the schoolhouse, because a lot of these things that need to be sustained moving forward, that need to be part of a program of record or part of the regiment moving forward, will die a death as soon as commanders change out. And we cannot risk that. You've got to stay connected to the schoolhouse. That's not to limit innovation, it's to synchronize innovation. You guys are learning such incredible things in the field every single day, but you got to stay connected back to Fort Leonard Wood, because that's the team that's going to help you make this change a lasting and permanent change that makes the regiment better tomorrow. So, General Watson, appreciate the opportunity to sit in on this. Great discussion, and this is a great time to be part of our Army and part of the Engineer Regiment. Thank you.
Okay, with that, we are adjourned. And again, my thanks to everybody. Really well attended by all compos. And thanks to the senior leaders and to our young leaders for all making their voice heard. And we'll see you soon. Essayons, lead to serve.